Technical problems happen all the time, but we hadn't even started the fraction unit yet. So we were starting from a fresh new unit, and I'll make sure that we get to the same spot between now and the next stream. So we're going to go to understand fractions. As always, this is a new stream, so I am going to once again very strongly recommend that you check out, I'm just taking a look at, okay, good, that you check out these videos. They are excellent. They are very, very good at explaining in a way that makes sense, and they serve as an excellent second voice that you can be learning this from other than just me. It's always good to learn from multiple voices, from multiple perspectives. So if you're watching this video, you clearly have some interest in learning this stuff. I strongly suggest you learn from both me and from the videos on Khan Academy proper. Okay. So now we're going to start talking about fractions. Now, fractions are probably going to come, and we're going to go to cut shapes into equal parts. The word fraction, if you really think about it, what does the word fraction even mean? Well, fraction sounds to me like fracture, which means to split up. Right? A fraction is a whole thing that has been split up in some way. Sometimes it's many whole things that have been split up in some way, but it involves some sort of splitting, and in math language, splitting usually means dividing, especially when we're talking specifically about splitting into equal pieces. And when we talk about fractions, we are talking about splitting into equal pieces. If I cut something into fourths, it needs to be into equal fourths, or else it's not fourths. It has to be into equal pieces is what I mean to say. So, which of these figures are divided into equal parts? Let's look a little bit closer. This one is clearly not cut into equal parts. Now, we're not even talking about the word fraction. We're not talking about numerators or denominators yet. We'll get to those. For now, let's just recognize what are and are not equal pieces. This is very important, because when we later on start to try to add fractions that have different denominators, this is what we would be doing. They would be unequal pieces. They would be pieces that one piece was bigger than the other, and they don't mix and match, or they don't mix very well. This one's close. These three pieces are equal, but this one looks like it's twice as big as the rest, so that's no good. And this one right here, C looks to me like it is a pentagon. It is cut into 1, 2, 3, 4, 5 triangles. All of those triangles look equal to me. I think that's the right answer, but we're going to go ahead and take a look at D as well. D is, again, it is cut into 4 parts, but it's all cut vertically. These two middle pieces are bigger than the two outside pieces. Therefore, this is not cut into fourths. And again, as I always have when I get to a place like this, I encourage you to think about how these various shapes can be cut into equal pieces. Like, think about all of the ways that maybe this hexagon here could be cut into equal pieces. It's not right now, but it could be if we moved those lines around a little bit. I did not hear. I did not hear the sound. That's unfortunate. Did I mute the site? No. My volume's working. Oh, well, I guess we don't have the happy Khan Academy sounds today either. I'm not sure what's going on. This is a week of technical difficulties for me. It's just the way it goes sometimes. Which rectangles have 1/3 of their area shaded? So now we're going to talk about numerators and denominators and why they are called numerators and denominators instead of just the top and the bottom of the fraction. So I have 1/3. All right. What do these numbers mean? Let's say I have an object. And yes, I see that there's an answer right there. Let's zoom in so that we can't see the answer. Let's say we have an object. If it's going to be 1/3, I should probably make it a circle. That's close enough to a circle. Shut up. If I want to make 1/3 of it, if I want to find out what 1/3 of that circle looks like, well, what do? I cut it into 3 equal pieces, like a peace sign, and I would shade one of those 3 pieces. So what does the 1 and the 3 actually do? What does it actually mean? The 1 tells us how many pieces. And one way that we can talk about that, another way of saying how many is to numerate or enumerate. That's why it's called a numerator. It literally means a thing that counts. In this case, it's only counting to 1. There's only 1/3. But it would be the same numerator if it was 1/6 or 1/10 or 1/20. The difference is that the bottom here, which tells us each piece is divided into how many, or each piece is how big. Not big as in actual size, big as in how much of the object is it, right? Obviously, like if I took half of a very small pie and 1/3 of a very large pie, that third might actually be bigger, even though 1/3 is technically smaller. We're talking about specifically how much of one object we're talking about. We could also see that as let's see, how do I want to put this? Pieces per whole. It's another way of putting it. How many pieces, equal pieces, remember we just did that last problem, how many equal pieces make up one whole? And that's called, just like with money, there's a 1 or a 5 or a 10 on that bill that tells you how much it is, right? It tells you how much it is. Oh, that's an excellent way of putting it. I could say that this is how much is each piece, or how much of a whole is each piece. Sorry about writing over writing. Let me see if I can fix that a little bit. There we go. That's a little bit better. There we go. So how much of a whole is each piece? If you think about things like a $1 bill or a $5 bill or a $10 bill, those are called denominations of money, right? A denomination is how much per dollar bill. If I have 15 $5 bills, the $5 is the denomination of the bill. That's why we call the bottom of a fraction the denominator. The denominator. Sorry, I'm a math teacher. I have to make that joke at least once. It's in the contract. It's not that these names were made up just to mess with you. They weren't. They're not overcomplicated just to be overcomplicated. They are telling you what they do. The numerator counts. The denominator tells you how much each piece is, how much of a whole each piece is. So when I say 1/3, it means that I've got one of them out of 3 pieces. So I'm going to erase that. And it looks to me like this very, very first answer right here is indeed 1/3. There are 3 pieces. They're equal. And one of them is shaded, 1/3. Keep this in mind as we continue. B is also 1/3. It's a different third, but it's still 1/3. C is also 1/3. Do you see how it is still split into 3 equal pieces, and one of those equal pieces is still shaded. It is still 1/3, even though it's split up in a different way. That one is not. This one does have 3 pieces, and one of them is shaded, but they are nowhere near equal, so we cannot call this 1/3. These names are not trying to trick you. I promise. That's not what they're here to do. They're here to make your life better, not worse. And when I hit that, I saw my what's it called? Audio mixer blip. So hopefully you all are hearing the Khan Academy sounds that for some reason I can't hear. Okay. So now we're going to cut shapes into equal parts. Still, the cake is cut into 6 pieces. Is each piece equal to 1/6 of the area of the cake? Now, area is a word that we only just started dealing with, right? We only just started talking about area, but yes, that's correct. If the cake is cut into 6 pieces and they're all equal, then each piece is 1/6. I actually don't necessarily like the way this is written. Notice how it does not say that the cake is cut into 6 equal pieces. They certainly look equal, but one of the through lines we're going to be seeing in math is you can't always trust the diagram. One of those could be very, 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 very slightly different than the other. It's not. Obviously, this is 3rd grade math, so the answer is yes, it's 1/6. But that's just, it's me pointing out that everybody sometimes is imprecise in their wording. It meant to say the cake is cut into 6 equal pieces. You can't just cut it into 6 pieces and assume that one piece is 1/6. Which figures are divided into equal parts? That one, and that's it. Which rectangles have 1/6 of their area shaded? So once again, it means that the rectangle is cut into 6 pieces and one of them is shaded. So let's take a look. 1, 2, 3, 4, 5, 6, and I just did it. 6 equal pieces. And one of them is shaded. C looks like 1/4 to me instead, right? 4 equal pieces, one of them is shaded. And then D is 1, 2, 3, 4, 5 pieces with one being shaded. So it looks like B is the only correct answer. This pizza is cut into 2 pieces. Is each piece equal to 1/2 of the area? It's, oh, I love it. Do you see this here? It's okay if each slice has different toppings. Yes, and this is exactly the kind of question that you will get at some point. Like, as a teacher, be ready for this stuff. If you put a piece of pizza here, and it's not perfectly symmetric, they'll be like, no, there's 3 olives on this side and only 2 and a half on this side, so they're not equal. You gotta be very clear as to what you mean. So I like that they got out ahead of it and said it's okay if each slice has different toppings. Equal parts, that one. And again, as we figure out which of these are equal parts and which ones are not, I want you to be thinking about what patterns we use to cut things into equal pieces. Because there are a few that we use over and over again, like this one here. You see how each one has a point in the middle? That is one way that we divide up objects. And that is cutting shapes into equal parts.